Good day, everybody. As you can see, today's lesson is a special topic. We're going to talk about math for the environmental engineering technician. And yes, you can do it. Every semester, without fail, it doesn't matter what the class is, there's always some small hint of math in there somewhere. And inevitably, people freak out when they see it. And that bothers me that people are so freaked out by math. It's just math. And math is not hard. I mean, you may think it's hard, but it's not really. It's all in the way you think about it. Are you a logical person? My guess is that you would consider yourself to be a fairly logical person. Math is just another language of logic, and hopefully I'm going to be able to teach you that language at least a little bit today. This is going to be done in two parts. As I said, this is going to be done in two parts. This first time we're going to be talking about some basic mathematics to show you that you actually do know a good bit of math already. And then in the next lesson we're going to actually do some problems and we're going to apply these. So yes, you can do math, and yes, you are going to do math. We're going to start out by talking about the basic math functions. These are the things that you see every day. And it's math, and you do it every day. Then we're going to step up to two-dimensional shapes and then to three-dimensional shapes, which would, most of you would probably consider this geometry, and you'll say, but I didn't do very well in geometry. It's not going to be that kind of geometry. There are no proofs. That was the hard part I had in geometry. And then we're going to do some very, very basic algebra, and then I'm going to show you a system for solving problems, and then again in the next lesson we're actually going to solve some problems. So, basic math functions. Manipulating numbers. You guys like the numbers right there? It's a little nice for you. Alright, so addition is the mathematical process of putting things together, also called combining sets. When you read a math problem, if you hear the word sum, then that's going to tip you off that you're going to need to be doing something with addition. Addition has commutative and associative properties. Well, first let's go back to this. Putting things together by combining sets. You've got 3 apples. Just pretend they're apples, alright? Use your imagination. Your friend has 2 apples. How many apples do you guys have together? Well, 3, your set, plus 2, your friend's set, equals 5. How many of you got that right away? I bet you all raised your hands, and that's good. So the sum of 3 and 2 is 5. Now, commutative and associative properties. Commutative properties, if 3 plus 2 equals 5, then 2 plus 3 equals 5 as well, right? Because 3 plus 2 equals 2 plus 5. That's what the commutative property is. It basically says it doesn't matter what order you do it in, it's going to come up with the same answer either way. The associative property says, well, let's say we got 3 numbers. Let's say we have 3 plus 2 plus 2. And let's say we add these up first. 3 plus 2 is 5, plus 2 is 7, right? What does this change? 2 plus 2 is 7, plus 3 is, 2 plus 2 is 4. Ha! See? We all make mistakes. 2 plus 2 is 4, plus 3 is still 7, so it doesn't matter where the parentheses go. That's the associative property. Anytime you add columns by place. So if you say, let's say you make $1,250.72 per paycheck, and then how much do you make in a month? Well, that's 1,250.72 plus 1,250.72. So here you have the hundredths position, the tenths position, the ones, the tens, the hundreds, and the thousands. And I bet if you tried really hard, You could do this math. 2 plus 2 is 4. 7 plus 7 is 14. Carry the 1. You see how we jump spaces? 0 plus 0 is 0. Plus 1 is 1. 5 plus 5 is 10. Carry the 1. 2 plus 2 plus 1 is 5. And 1 plus 1 is 2. So we carry the comma down. We carry the decimal down. So in a month you make $2,501.44 until your taxes come out, and then you end up with $5.21. You guys can do that kind of math, right? It's addition. Now let's say we have a common denominator. Let's say we want to add 7/8 of an inch plus 1/2 an inch. Ooh, how do you do that? Is that 8/10? No. What you do is you find the common denominator. 7/8, the common denominator here is 8, so that would be 7/8 plus 4/8, which is 7 plus 4 is 11, right? Which is 11/8. You can carry that, and if you want to make a mixed number, you can make a mixed number. That's 1 3/8. If my math is correct. See? Are you having problems so far? I seriously doubt it. I think you guys are all doing perfectly fine. So, let's look at subtraction. Subtraction is the inverse of addition. In the word problem, you look for the keyword of difference. So if we come back up here, and let's say you got your 2,501.44, 2,501.44 in a month, and you've got a house payment of, I don't know, $924.90. Can you do that math? I certainly hope so. So let's say 4 minus 0 is 4. 4 minus, can you subtract 4 from 9? No. You got to come over here. That gives you 14. You're going to borrow from here. And it's going to be 11, but you had to borrow, so it's actually 10. And this is going to be 9. And this is going to be 4. Did I do that right? Probably not, because I'm not paying attention to what I'm doing. So 9, 10, 11, 12, 13, 14 is 54 cents. 10 minus 4 is 6. 9 minus 2 is 7. Yeah, that's better. 14 minus 9 is 5. Is that right? It seems about right. Well, I'm not sure. How are we going to check? Well, because this is the inverse of addition, what we can do is 1,576.54 plus 924.90. 4 plus 0 is 4. 9 plus 5 is 14. Carry the 1. 6 plus 4 is 10. Plus 1 is 11. 7 plus 2 is 9. Plus 1 is 10. 9 plus 5 is 14. Plus 1 is 15. 2501.44. Hot dog, I did my math right. Go figure. But did you see how I did that? Of course you did, because you've been doing this since elementary school. You don't need me to tell you this, right? Right. I mean, why am I taking the time to talk about math? I mean, this is simple math. This is arithmetic. This is stuff you've done since elementary school. I know. Just bear with me, if you would, please. Multiplication, you've either got this x or a star or something like that. It is the mathematical operation of scaling one number by another. Just like addition, it is commutative and associative, so it doesn't matter what order you do it in. 5 times 4 is the same thing as 4 times 5. It is also distributive, so that x times y plus z is the same thing as x times y plus x times z. We're going to probably use that a little bit later on. I'm sorry. That should be incidentally z, not x. You should always go back and read your slides. Another little interesting thing about multiplication is the identity element. Any number times 1 is that number. Anything times 1 is whatever it was. So quail times 1 is quail. Castleberry times 1 is castleberry. Z times 1 is Z. 9 times 1 is 9. Anything multiplied by that 1 gives you that same identity. That's not hard, right? You knew that? Good. There's also the 0 element. Any number times 0 equals 0. 9 times 0 is 0. 1,536 times 1,536 times 0 is 0. 4,302,752,992.7891 times 0 is 0. Castleberry times 0 is 0. The inverse property for all numbers other than 0, 1 over that number times that number equals 1. Very important here, because this is going to be helpful for solving equations. So 1 over 2 times 2 equals 1. 1 over x times x over 1, and x over 1 is the same thing as x, equals 1, because the x cancels out. In this case, 2 is the same thing as 2 over 1. The 2's cancel out. 1 over 1 is 1. 1 over goose times goose. Goose cancels, gives you 1. Why did I come up with goose? I have no idea. But any number times its inverse is going to give you 1. For multiplication, we don't have to find a common denominator. So 1/4 times 3/8 equals 3. 8 times 4 is 32. Is that right? There you go. Problem solved. Yes. Sometimes my math skills aren't so sharp either. How about that? Imagine. They do fine for what I need them to do though, and that's all I'm going to get you. Your math skills need to be able to do what you need them to do. It's just logic. People have a tendency to mess up. People have a tendency to do two things. Number one is fear the logic. I don't fear the logic. When we're done, you're not going to fear the logic either. And number two, make simple arithmetic errors. Everybody's going to do that from time to time, so don't worry about that. Just double check your work. Division is the same thing. Well, it's not the same thing, but it is the inverse of multiplication. So instead of going out, you are actually partitioning. So if you've got a pizza pie and you cut the pizza pie, you got 8 even slices, then you have divided it. And you can have this piece right there, and I get all the rest. And that's division. Division of any number by 0 is not defined, so 8 divided by 0, not defined. 1 divided by 0, not defined. 0 does not belong down here. Any number divided by itself is 1. 8 divided by 8, 9 divided by 9, goose divided by goose, x divided by x, p divided by p. You get the idea? Also very important, as you're going to see later. Where's my button? There's my button. Exponents is a simple form of multiplication where the base is multiplied by itself y times. So for example, if we have 2 to the 3rd power, that's 2 times 2 times 2. So for example, 2 times 2, sorry, let me try that. 2 times 3 equals 6. 2 to the 3rd, 2 times 2 is 4, times 2 is 8. In fact, we could do it this way. 2 to the 1st versus 2 times 1. Both of those are equal to 2. 2 squared is the same thing as 2 by 2, which is 4. 2 to the 3rd equals 2 times 2, which is 4 times 2, which is 8. whereas 2 times 3 equals 6. 2 to the 4th equals 2 times 2 times 2 times 2, which is 16. 2 times 4 equals 8. 2 to the 5th equals 2 times 2 times 2 times 2 times 2, which is the same thing as 32. 2 times 5 equals 10. So you see the difference between an exponent and just standard multiplication? For this reason, right here, because there is this exponential growth, if you were to graph an exponential, this is what the graph would look like. There's an exponential curve sort of flattening out. So, for example, 9 to the 8th is the same thing as saying 9 times 9 times 9 times 9 times 9 times 9. 1, 2, 3, 4, 5, 6, 7, 8. That's the same thing. Got that? That's not the same thing. 9 times 8 is not the same thing as 9 to the 8th. Alright? Are we good there? Good. Roots are the mathematical inverse of components. I'm sorry, exponents. So if we come back here and we say, let's see, the square root of 32 should give us 5, right? 32 square root 5.65. In other words, what two numbers multiplied by times each other equals 32? We can take the third root, we can take the fifth root, we can take the 17th root. But what number multiplied by this number by itself this number of times gives you that? You don't see roots very often, but they are the mathematical inverse of exponents. So just remember that in case you have to manipulate a formula that way. Order of operations. So let's say that we have, and I'm just totally making this up, so I'm guessing it's probably not going to work the way that I want it to work. Say 2 plus 2 times 4 minus 8. What does that equal to? Well, you could do it straight across. 2 plus 2 is 4, times 4 is 16, minus 8 equals 8, right? Or you could say 2 times 4 is 8, plus 2 is 10, minus 8 equals 2. Or you say 4 minus 8 is negative 4. Negative 4 times 2 is negative 8, plus 2 is minus 6. So you could do that in a lot of different ways. However, that's not the way it works. There's an order of operations, so it tells you what we're going to do. First we say, please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. That's the order that we're going to do it in. There are no parentheses, so we don't do that. There are no exponents, so we don't do that. Multiplication. 2 times 4 is 8. Addition. 8 plus 2 is 10. Subtraction. 10 minus 8 equals 2. So here's your correct answer, because we follow that. Same thing we could do, I mean, you could do this any number of times, but always follow this. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. Order of operations. How much time have we got? I want to stop right here, and when we come back, I'm going to do two-dimensional shapes, and maybe when we get done with that, we'll have time to do three-dimensional shapes. Alright, so that's it for the time being.